introduction of Spark. Let's learn something Python and Spark. Before we begin, we set up the coding with Python and Spark. Let's discuss with the Spark and the context of big data. We will begin with the general explanation what the big data is and related to technology. So guys, what is the big data? So big data we can explain like data which is having a lot of volumes, a lot of variety of data and a lot of versatility of data. So explanation of MapReduce and the Spark. A lot of people are comparing between Hadoop and Spark. It's not Hadoop and Spark. It's the comparison between MapReduce and Spark. Local, we can learn. We can start Spark as a local as well as a distributed system. Overview of Hadoop ecosystem. Data can be fit in local computer in a why we need big data. Scale up to 32 GB depending upon the RAM. But what can we do if we have a larger set of data? Try to use SQL database, move the storage onto drive instead of RAM. Or use a distributed system that distributed data multiple machine in computer. So here you can see the typical local system and here the typically distributed system. In local versus distribution, local we have in local we can have several cores, but if it is fail when we got a more large amount of data. Here in distributed we can have a lot of we can leverage the low cost machine and we can add the big data. So local process will use the computation resource in the single machine, and in distributed process has the access the computation resource across the number of machine unconnected through the network. After a certain point, it is easier to scale out the many lower CPU machine than try to scale up to the single machine with a high CPU. Distributed machine also have the advantage to easily scaling. You can just add one more machine. So what is big data? They also include the fault tolerance in the big data. If machine is failed, the whole network can still go on. Let's discuss a typical form and distributed architecture that use the Hadoop. So Hadoop is the way of distribution way of large file across the multiple machine. It uses the Hadoop distributed file system which is called HDFS typically. HDFS is allow user to work in the large data sets. HDFS also duplicate the block of data for fault tolerance. It's also then use the MapReduce. MapReduce allow to computation on the race data. So if you see here distribution storage, CPU, RAM, name node, data nodes. In distributed storage, HDFS will use a block of data with the size of 128 MB by default. Each of these blocks is replicated in 3 times. The blocks are distributed in the way of support of fault tolerant. Distributed store HDFS, a smaller block provide more parallel during the processing. Multiple copy of the block prevented loss of data due to the failure of the nodes. MapReduce. MapReduce is way of splitting a computation task distributed in a set of such as HDFS file. It consists of job tracker and multiple task tracker. MapReduce job tracker is a send run on the task tracker. The task tracker allocate the CPU and memory the tracker and monitor the task on the worker nodes. Big data. What we cover in this into two distinct using the Hadoop distinguish large data sets using MapReduce to distributed a computational task distributed in data set. Next, we will learn about the latest technology in the space of known the Spark. Spark improve on the concept of using distribution. So Spark. So Spark works as MapReduce, Spark RDD, Spark data frame. Now the next generation Spark is coming with the data frames. Spark is the largest technology being used in the quickly and easily to handle the big data. It's an open source project of Apache. It was first released in February 2013 and has exploded in popularity due to its easy to use and speeds. It was created in AmpLab in UC Berkeley. You can think the Spark is a flexible alternative of MapReduce. Spark can use the data stored by a variety of format, Cassandra, AWS, HDFS, and more. MapReduce requires the files to be stored in HDFS. Spark does not. Spark also can perform operations up to 100 times faster than the MapReduce. So how does it achieve this speed? MapReduce write the most of data in the disk after each of map and reduce operation. So Spark keep most of data in memory after each of transformation. Spark can spill over the disk if the memory is filled. Spark RDD. At the core of Spark is the idea of resilient distributed data set. Resilient distributed data set has a four main function. It's distributed and fault tolerant parallel operation, ability to use the many data source. And here you can see the Spark RDD. The driver program is where it's connected to the worker nodes. And when we create a Spark context, Spark context is nothing but it's basically connections of the worker nodes. And cluster manager is manage the clusters. Worker nodes. Each worker node have its own task and cache and executor. So typically RDD you can see in the production environment, like one is the master node, other is the slave node. Slave nodes have is the memory, RAM, and disk. So what I can say, the RDD are immutable, lazy evolution, and cacheable. So there are two types of Spark operation which we can perform: transformation and action. Transformation are basically receipt of the follow. Action is usually perform what a receipt say to and return the something to back to machine. Spark RDD behavior of carries over the Spark syntax when the coding. A lot of times you will write a method call, but you won't see anything as a result until you call the action. This is make the sense because with the large data sets, you don't want to calculate all the transformation until you are sure what you want to perform them. When we discussing Spark syntax, you will see the RDD versus data frame syntax are now. With the release of new 2.0, Spark is moving towards data frame based syntax, but keep in mind that while files being the distributed can still throw the RDD, it's just type out of the syntax that caching. We covered Spark RDD and Spark data frame also we will cover in this topic, and we can go in the spark.apache.org documentation part, and where you can get all the documented in the Java, Scala, Python, and R. Thank you.